In this outcome, we open up the computer itself and look at the two halves that make it work: hardware, the physical parts you can touch, and software, the instructions that bring them to life. Neither is much use without the other, as we're about to see. Let's set out the ground we'll cover. A computer is really a partnership. Hardware does nothing until software tells it what to do, and software can't run without hardware to carry out its instructions. Think of a games console, where the box and controller are hardware, but it's a dead lump of plastic until the game and the system software load. We'll define both, weigh up internal and external devices, and sort out the different kinds of software. First, the two definitions. Hardware is the physical, tangible kit: the processor, the memory, the hard drive, the keyboard, the monitor, anything you could actually pick up. Software is the programs and data, the sets of instructions that tell that hardware what to do, like Windows, Chrome, or a spreadsheet. The relationship is the key thing. Hardware is useless without software to drive it, and software has nowhere to run without hardware underneath. Every computer, from a phone to a server, follows the same simple pattern: input, process, output. Input devices bring data in, the processor works on it, and output devices show you the result, while storage holds everything before and after. Picture typing a message where the keyboard is input, the chip processes it, and the screen is output. This little model lets us classify almost any device by the job it does. Hardware splits neatly into two camps. Internal hardware lives inside the case and does the core work: the CPU, the RAM, the motherboard, the power supply. External hardware, the peripherals, plugs in from outside, usually by USB, HDMI, or wireless. So that's your keyboard, mouse, monitor, or printer. Interestingly, the same job can sit either side of the line. A webcam might be built into your laptop lid or clipped on as a separate device. Let's meet the three components that matter most inside. The CPU is the brain, and it does the actual calculating, rated in gigahertz and cores, like an Intel Core i7. RAM is the fast-working memory that holds whatever's running right now, but it's volatile, so it empties the moment you switch off. And the motherboard is the big circuit board that ties everything together, letting the processor, memory, and everything else talk to one another. It helps to weigh these parts up honestly, because each has a downside. A powerful CPU gives fast, general-purpose processing, but it runs hot and becomes a bottleneck if it's underpowered. RAM gives lightning-quick access to open programs, but it's volatile, and adding more can get pricey. An internal SSD boots and loads in a flash and has no moving parts, though it costs more per gigabyte, and a graphics card is brilliant for visuals and AI work while being expensive and power-hungry. The same balanced eye applies to peripherals. A keyboard gives fast, accurate typing, but it takes desk space and can strain your wrists over a long day. A laser printer is quick and sharp with a low cost per page, yet it costs more upfront and needs toner. A webcam opens up video calls but carries a privacy risk, and an external SSD is wonderfully portable for backups, right up until you lose it or it's stolen. Devices generally do one of three jobs. Input devices send data in, so that's keyboards, mice, scanners, microphones, and touchscreens. Output devices present the results, like monitors, printers, speakers, and projectors. And storage devices hold data and programs, from an SSD or hard drive to a USB stick, an SD card, or the cloud. A few clever devices do more than one job at once, and a touchscreen, for instance, is input and output rolled into one. Storage is worth a closer look because the two main types pull in opposite directions. A solid-state drive, or SSD, is very fast, silent, and robust with no moving parts, which makes it ideal for your operating system and apps, but you pay more per gigabyte. A hard disk drive gives you loads of space cheaply, perfect for bulk storage and backups, though it's slower, noisier, and those spinning platters can fail if you knock it. Many machines use both, a small SSD for speed and a big hard drive for everything else. Zoom out and storage forms a neat hierarchy, trading speed against size. Right at the top, the registers and cache inside the CPU are blisteringly fast, but tiny. Below them sits RAM, the fast main memory, and then your SSD and hard drive as the big backing store. As you move down, storage gets cheaper, larger, and slower. So choosing it always means balancing speed against capacity and cost. Let's put that judgment to work. A college is kitting out a graphic design classroom on a fixed budget. For input, graphics tablets and high-resolution scanners suit design far better than basic mice. For output, big, color-accurate monitors matter more than a speedy printer. And for storage, a fast internal SSD handles the files people are working on, with network or cloud storage for backups. The lesson is that the best device isn't the most powerful one. It's the one that fits the task, the users, and the money available. Now to software, which sits in layers between you and the hardware. Down low is system software, which runs and manages the machine itself. Up top is application software, which helps you get a job done. And right in the middle sits the operating system, connecting the two. Think of it as a stack. So when you click a button in an app, your request travels down through the operating system to the hardware and back up again. Let's break system software into its main types. The operating system is the big one, and it manages the hardware, the memory, your files, and everyone using the machine, whether that's Windows, Mac OS, Linux, or Android. Utility software is the collection of small maintenance tools like antivirus, backup, and disk cleanup. And a device driver is the little translator that lets the operating system talk to a specific bit of kit, such as your printer or graphics card. A few more pieces belong in the system software family. A compiler takes a whole program written in a human-friendly language and translates it into machine code all at once, producing a file that then runs quickly, like a C++ compiler. An interpreter does it differently, translating and running a program one line at a time, which is flexible for testing but slower, and Python works this way. And firmware is the low-level code baked onto a chip that gets the hardware going the moment you press power, like the BIOS. That compiler versus interpreter distinction is worth nailing down. A compiler translates the entire program before anything runs, giving you a fast, standalone executable, and it flags errors only after it's chewed through the whole thing, which is how C and C++ work. An interpreter translates and runs line by line, which makes testing and debugging far easier and more interactive, but the code runs more slowly, so think Python or JavaScript. Neither is simply better. They suit different jobs. Let's give the operating system its due, because it's quietly doing an enormous amount. It manages the processor, deciding which program runs and when. It hands each program the memory it needs. It looks after your files through a system of folders, and it talks to your devices through drivers while giving you a screen to work on. When you hit save, for instance, it's the operating system that finds room on the disk and updates the file system for you. No fuss required. Application software is the part you actually choose to open, and it's there to help you do real-world tasks. There's productivity software like word processors, spreadsheets, and presentation tools. There's communication and web software like browsers, email, and video calling. And there's creative and specialist software, from photo editing to accounting to games. Whatever the app, it always leans on the operating system beneath it to reach the hardware. Let's set the two kinds of software side by side. System software runs and manages the computer, mostly working away quietly in the background from the moment you switch on. So that's Windows, drivers, and antivirus. Application software helps you do a specific task and only runs when you decide to open it, like Word, Chrome, or Photoshop. The crucial difference is dependency. System software works directly with the hardware, while applications always need that system software sitting underneath them. Here's an everyday moment where all the layers cooperate. A student writes an essay and prints it on a college PC. Microsoft Word, the application, lets them type and format. Windows, the operating system, manages the memory and saves the file to the drive. The printer driver quietly converts the document into signals the printer understands. And antivirus, a utility, checks files in the background the whole time. 4 different layers, one simple task, all working in concert. Let's pull this outcome together. Hardware is the physical kit, and software is the instructions, and each is useless without the other. Internal parts, like the CPU, RAM, and motherboard, do the core work, while external peripherals connect around them. And every device is really an input, an output, or a store, with storage forming that speed, cost, and capacity hierarchy. On the software side, system software runs and manages the machine, while application software helps you get things done, always relying on the operating system beneath it. And that wraps up our tour of hardware and software. We've defined both, weighed up internal and external devices, sorted the storage hierarchy, and untangled system software from the applications you use every day. If you want to dig further, the reading points you to Tannenbaum on how computers are organized and Silberschatz on operating systems, both of them standard texts. For something lighter, BBC Bitesize and Microsoft Learn have friendly explainers, and the story of the shift from hard drives to SSDs makes a great real-world case study. Take a look, then carry on when you're set.